Hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the equivalent inductance of this particular electrical network. Okay. So as you can see, the 20 millihenry inductor and 30 millihenry inductor are connected in series with each other. Okay. So the resultant inductance will be equal to 20 plus 30, 30, which is equal to 50 millihenries. Okay. And the combination of these two inductors is connected in parallel with 50 milliohm inductor. Okay, since these two inductors are connected in parallel with this inductor, so we can just find the equivalent inductance of this particular combination. Okay, so the series combination of 20 plus 30, okay, in parallel with 50 millihenry inductor. Okay, so that is coming out to be 50 into 50 over 100, which is equal to 25 millihenries. Okay, since this particular resultant is connected in series with the 75 millihenry inductor, so the equivalent inductance will be equal to 75 plus 25, which is equal to 100 millihenry. Okay, so I hope it is clear how we are able to find the equivalent inductance of this particular network. Okay, now let's start with the second problem. Okay, so in this particular equation, so in this particular network, we need to find the equivalent inductance. Okay, let's say this particular node is A. Okay, so since this particular node is branch, so it means that this node will also be equal to A. Similarly, if this node is B, then this node is also equal to B. Okay, so it means that since all the 3 Henry inductors are connected between the same node A and B, it is also connected between A and B. So it means that these 3 inductors are connected in parallel with each other. Okay, so the equivalent inductance will be equal to 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3. Okay, since the inductance of all the inductors are 3 Henry, it means that which will be equal to, so it will be 1 by 3 plus 1 by 3 plus 1 by 3. So that is coming out to be your 3 upon 3, which is 1. Okay, so L equivalent is equal to 1 Henries. So I hope it is clear. Okay, so let's find the equivalent inductance of this particular electrical network. Okay, so in this particular electrical network, you can see that 40 Henry and 100 Henry inductors are both connected in series with each other. It means that the resultant of these two combinations will be 40 plus 100. Okay, and these two inductors are connected in parallel with the 50 Henry inductor. So we can say that the equivalent inductance L equivalent will be equal to, so L equivalent will be equal to 40 plus 100 in parallel with your 50 Henry inductor. Okay, so that is coming out to be 140 into 50 over 190. Okay, so which is equal to 700 over 19, which is your 36.84 Henries. Okay, so this will be the resultant network. Okay, after finding the equivalent resistance, so this will be equal to 36.84 Henries. Okay, so as you can see, these two inductors are connected in series, and their series combination is connected in parallel with the 30 Henry inductor. So the equivalent inductance of these 3 inductors will be given as, okay, so it will be equal to L equivalent is equal to 20 plus 36.84 in parallel with your 30 Henry inductor. Okay, so that is coming out to be 56.84 into 30 over 86.84. Okay, so that is coming out to be your 19.6 henries. Okay, so this will be your equivalent circuit. Okay, after finding the resultant magnitude of the equivalent inductance. Okay, so in this particular circuit you can see that this 40 and 19.6 ohm 6 henry inductor are connected in series, and similarly their parallel combination is connected with 20 henry inductor. Okay, so it means the total inductance or the equivalent inductance will be the parallel combination of 40 plus series combination of 19.40 and 19.6 henry inductor in parallel with 20 henries. Okay, so that is coming out to be your 59.6 into 20 over 79.6. Okay, so after further solving it we are getting, so that is equal to 14.97 henries, which is approximately equal to 15 henries. Okay, so I hope it is clear. So that's all for today guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.